So now let's solve some equations using the elimination technique. And we're going to be on page 360, and this is going to be number 7. And it says that we have x plus y equals 2, and we have negative 3x plus 4y equals 15. Now, the way this question is set up is that we have an x and a y for both of these equations, and the x and the y are going to be the same number. So if we have two equations and two unknowns, we can solve it. And we're going to solve it by adding these two equations up. Now, if we add these up, just like how they are right now, we'll have 1x, remember this is a 1 right here in front of the x, 1 plus a negative 3. So that'll be a negative 2x right here. And if we add this up, we'll have 1y plus a 4y, be 5y here. And we don't want that. The purpose of doing the elimination technique is to get either the x or the y to be eliminated from the equation. So what we're going to end up doing is we're going to find a common multiple of both of these equations that that we can eliminate either the x or the y. We can just we'll pick one. So this is kind of like finding the common denominator when we added fractions. And so if we can just have like a little side note over here, whenever we have something kind of like 2 over 5 plus let's say 1 over 10, what is that going to equal? Well, what we would do to solve this, these two fractions right here, when we add them up, we got to get the bottom number to be the same. So the common denominator between both of these would be 10. You can use 50 or maybe another number, but we could just leave this as a 10 right here, and just change this 5 to a 10. And to do that, we're going to multiply this by a 2 over 2. And 2 over 2 is going to be 1, so we're not going to change this at all. We'll have 2 times 2 will be 4, and divided by 2 times 5 will be 10. So this 2 over 5 became a 4 over 10. And this will just carry down 1 over 10, and we'll add these up now. The bottom number will still be 10, and we'll have 4 plus 1, 5. So 2 over 5 plus 1 over 10 is going to be 5 over 10. Now, the concept of getting the common denominator like this is going to apply over here. And here's what we'll do. We got a 3 right here, and we got a 1 right here. So if we had another example where I had something like 2 over 1, and that could be like this 1 right here. We can have like, a 1 right here, and that would be like this 1 right here. And we wanted to add that up with another fraction. Let's say we have a 3 right in here, and this 3 right here would represent this 3 right here that's part of the equation. So if we're going to add that up, let's say we'll make up a number just like a 1. And we want to add these up. What we would do is we'll just multiply this right here by a 3 over 3. Then we would get 3 times 2 would be 6, and we divide that by 3 times 1 will be 3. So then we can just take this right here and add it to this plus 1 over 3. And that would be 6 plus 1 would be 7 over 3. So we're going to use this exact same idea. So to do that, I'm going to end up multiplying all of this equation by I'm going to multiply all of this equation right here by a 3. I'll move this 7 over here. This is number 7 in the problem. And just like how I multiplied this by 3 here to this 1, I multiplied this 3 with this 1. But when I do that, I have to multiply everything in the problem. So this 3 will actually go to this it'll go to this, and it'll go to this. So I'll have 3 times 1 would be 3x, 3 times y, and this is a positive, so I got plus here, will be 3y. Then I have the equal sign here, and I have 3 times 2 will be 6. So basically, this equation right here just became this equation right there. So now all I'm going to do is take this equation and just bring it down. It's going to stay the same. I'm not going to multiply anything by it, just like I didn't multiply anything over here with this 3. So I'm going to have a negative 3x plus a 4y, and that'll equal 15. Now I'll add these two equations up. So I have 3x plus a negative 3x, and 3 plus a negative 3 will be 0. So this whole equation right here, or this part of the equation, the x, will just go away. Let's see, now I have 3y plus 4y. So that'll be 7y. And then I'll have equals. Now I got 6 plus a 15 will be a 21. So now I'll solve this for y. I got a 7 right here upstairs. So I can get 7 downstairs. So I got 7 divided by 7 will be 1. That'll cancel out. I divide this side by 7. I got to divide this side by 7. So y equals 3. Now that I know that y equals 3, what I have to do is I have to solve this for x. So to solve this for x, what I'm going to do is I'll pick an equation that I started with, and I'll plug y in, and I'll see what I get for x. So I'll take this equation right here, but you can pick any either one of them. So I have x plus y equals 2. And you could use this one as well, or this one. Doesn't matter which one you pick. You can use any one of these 4. But I'm just going with this one because it seems like the easiest. Now y is going to be 3, so I'm going to take this 3 and plug it in for this y right here. So I have x plus 3 equals 2. Now to solve this for x, I'll just minus 3 over here, and that's gone, and minus 3 over here. So I'm going to have x equals a negative 1. So now I have these two equations, and I have a x equals negative 1 and a y equals a negative 3. Okay, so we're still on page 360, and let's work problem number 14. And 14 says that we have 8x plus 3y, and that's going to equal 4. And we have a negative 7x, and we have a plus 5y, and that's going to equal a negative 34. Now, to solve this equation using the elimination technique, I need to first figure out which one am I going to eliminate. Am I going to eliminate the x, or am I going to eliminate the y? And for this one, I'll choose the y. I'll get rid of this y, so I have nothing but x over here. So to do that, I got to get the y's to have the same number, and they have to have the opposite sign. I'm not sure if I said that before. These y's are both positive, so I'm going to have to make one of them negative to get rid of these y's by elimination. And I'll show you what I mean by that in a second. So we'll add these two equations up, but before I do that, I have to multiply each one of them by a number so that I get these y's to be the same. And what I'm going to do is I use this technique where I have a 5 right here. I'm going to put that same 5 over here. And then I have a 3 right here. I'm going to take that 3 and I'm going to put it over here. Now what that's going to do is I'm going to have a 5 here, and this 5 will go times the 3, and then this 3 right here will go times this 5. So 3 times 5 will be the same number as 5 times 3. So these will both be 15, but the thing is, if I multiply this 5 times 3, I'll get a positive 15. If I multiply this 3 times this 5, I'll get another positive 15. So when I go to add these two equations up, I'm actually going to get a positive 30 if I left it like this. And I don't want that. I want them to eliminate. I want to get rid of them. So to do that, I have to make one of these a negative. It doesn't matter which one. I'll make this one a negative. So when I multiply this 3 times this 5, I'll get negative 15. And up here, I'll get a positive 15. So let's do that. We'll do this 5 times this 8. And when we do that, we'll get a positive 40x. So we'll have a 40x here. Now we'll have this same 5 times this 3. And when we do that, we'll have this is positive and that's positive, so we'll get a plus 15y equals. Now we're going to do this one more time. This goes to everything. Remember, it goes even to this way over here. So we'll have that 5 times 4. So that'll be a 20. So what happened was this equation right here, this equation just became this equation. Now we got to make this equation, and I'll take that one and I'll put it right under this, and then we'll add them up. So to do that, I'm going to have to take this 3 here and distribute it just like I did up here. So this 3 goes to this 7, it goes to this 5 right here, and it goes to this negative 34 over there. So we'll have a negative 3 times a negative 7, and we'll get a positive 21x. And then we'll have this negative 3 times this positive 5, and we're going to get a negative, because a negative times a positive is going to be a negative, and that'll be 15y. Then we'll have an equal sign, and I'll have a 3 times, or a negative 3 times a negative 34 will be a positive number, and that will be 102. So now that I got 15 up here and then 15 over here, and they're opposite in signs, I can now add them up and use the elimination technique. So we're going to add these up. So we'll have positive 40 plus a positive 21, so we'll get a 61x here. Now we got 15 here and negative 15 here, so that's just going to cancel out. So all of this will just go away. So this is now gone. So now we just have this equal sign over here, so that equals, we got 20 plus a 102. So that's going to be 122. So now we eliminate the y. All we got left is this equation right here, and we just got an x. So I'll divide this side by 61. I got a 61 upstairs, 61 downstairs. That's going to eliminate and go away. Now I'll do 61 divided by 61 over here, and I'll have 122 divided by 61. It's going to be x equal to a 2. So now that I got x, I'm going to solve this for y. Now to do that, I'm just going to pick one of these equations. It doesn't matter which one. So just to give me a little bit more room, I'll erase some of this and try to separate it out. So I got x equals 2. So I'm going to pick this equation, and I'll have 8 times 2 plus, we got 3y equals 4. So if we do 8 times 2, we'll get 16 plus 3y equals 4. Now, to solve this for y, I got to get rid of the 16 over here, so I'll do minus 16 on that side, and now that's gone. I'll do minus 16 on that side, so left over, I just got this 3y, and that's going to equal 4 minus 16, which will be a negative 12. So I'll have negative 12 down here. So I'll divide this side by 3, and that's gone. Now I'll divide this side by 3, and I get y equals a 4. So I got x right here and y right here for these equations. And this 4 right here should be a negative because we got negative 12 divided by 3. It's going to be a negative 4.